let's start by talking about the steps for going from a name to a formula. So we've gone from formula to name, but now we're going from name to formula. And the first 3 steps are the same no matter which method you're going to choose to use. So we're going to be learning 2 methods, the crisscross method and the LCM, or least common multiple method. And the first 3 steps are the same for all of them. The first step is to write your cation formula. The second step is to write your anion formula. And the third step is to write the ionic equation, because you have to remember you're always adding things together to form a compound. And I don't want you to forget that your balanced compound is a result of adding things together. Then for step 4, you're either going to do the crisscross method or you're going to do the LCM method. And for the crisscross, you do the LCM, the crisscross method. For the LCM, you have to create your LCM chart. And then you're going to write your balanced ionic formula, remembering for compounds or things that had subscripts already when you wrote down your cation and your anion. If you have more than one of them, you do have to put them in parentheses. And you never write a subscript of 1, because writing it the first time counts as that subscripts. The subscripts are always 2 or higher. So now we're going to talk about the LCM method. And we're going to remember that the first 3 steps are the same. The first thing is you always have to start with the name of a compound. So we're going to start with iron 3 oxide. Once you have the name, you're going to pull apart the cation from the anion. So we can deduce that iron 3 is our cation for 2 reasons. 1, it's written first, and your cation is always written first. And 2, if you look up iron on the periodic table, it's in the transition metals, and metals are always cations. And because it's a transition metal, we are given the charge in Roman numerals. So iron 3 is written Fe 3+. Then we have oxide, and we can deduce that oxide is our anion for multiple reasons. The first reason is it's written second, and anions are always written second. 2, we can look at the root of ox, which goes with O, which goes to oxygen. Oxygen's in the 16th column, which is a non-metal, and non-metals are always anions. And the 16th column has a charge of 2 negative, and anions are always negative. So we can write oxide as O2 minus. Then you can write the chemical equation, or sorry, the ionic equation as Fe3+. And you're adding that to O2 minus. Once you have that, you can start thinking about what is your LCM. LCM being the least common multiple, or the lowest number, both of these will go into as a whole number. Because remember, you cannot have like half or partial subscripts. We're only looking for full number subscripts. So when I'm looking at the LCM of 3 and 2, the LCM would be 6. And then you can pull down the information into your LCM chart. So here's the information you're going to pull down. You're pulling down your element name, or your symbol to be Fe. And then you're pulling down the charge number. So the charge number of Fe is 3. We're going to pull down oxygen next. So we can pull down O, and we know that the charge number of oxygen is 2. Then we can set up our LCM chart. So these are your charges. We know that 3 times something, we put a thing there, is going to equal your LCM of 6. And we know that 2 times something is going to equal your LCM of 6. You use the same LCM. When you fill out this equation, when you find out those 2 numbers, those are your subscripts. So 6 divided by 3 is 2. So 2 times 3 is 6. And then so 2 times 3 is 6. You have to fill in that number there that makes this true for both this and this. That means you can look over here now. Neither iron or oxygen is a compound, so we don't have to worry about subscripts messing up the original compound, so we don't have to worry about parentheses. So we can just write that new number as its subscript. So it ends up being Fe2O3. Here we go. Let's do another example for the LCM method. For now, we're going to do sodium nitride. Okay, as always, the first that you're doing is separating your cation from your anion. So when we look at sodium nitride, we know that sodium is the cation for 2 reasons. One, sodium was written first, and your cation is always written first. And 2, sodium's in column 1. 1 is a metal, and metals are always cations. And 2, we know the charge of column 1 is 1 positive, and cations are always positive. It's right in the name cat, and they have pods. So the cation we can write down as Na1+. The anion we can deduce as nitride for a couple reasons. One, it's written second, and the anion's always written second. 2, NITR is the root of N. N goes with nitrogen. Nitrogen's in column 15. Column 15 are nonmetals, and anions are always nonmetals. And 2, column 15 has a charge of 3 negative, and we know that anions have a negative charge. So we can write this anion as N3-. For the ionic equation, we just always write that to remember that we're adding things together. So we're doing Na1+ plus N3-. Then you can do the LCM. Now looking at 1 and 3, the lowest whole number that they both go into is 3. So we can do the LCM is 3. Then we can go ahead and do our LCM chart. You pull down your cation first, we put Na here. And we go ahead and pull down the cation charge of 1. We then go ahead and pull down our anion, which is N, and our anion charge of 3. Then, using math, we know that 1 times something and 3 times something will give us our LCM number of 3. So we just have to do the math problem. What times 1 equals 3? Well, anything times 1 will be itself, so this has to be 3, and this has to be 1. Now, the numbers we figured out are the subscripts. How many of each are in the balanced compound? So we can then just pull these numbers down to balance the compound. So we have Na3, and then we have to write N. But N has a subscript of 1, and remember, we don't write subscripts unless they're 2 or higher. So we just write N the 1 time, and we know we have a balanced compound. Okay, let's do another LCM of copper 2 peroxide. Well, the first thing you have to do is separate your cation from your anion. Well, we can know that copper 2 is our cation because it's written first, and your cation is always written first. Also, if you look up copper on the periodic table, you'll see that it's in the transition metals. And transition metals are metals, and metals are always cations. Additionally, because it is a transition metal, you had to be given the charge in Roman numerals, which you were given there. So we can write the cation as Cu2 plus. Then we get to deduce that the anion is peroxide for two reasons. One, it's written second, and your anions are written second. And two, peroxide is a polyatomic that we learned is O2 2 minus. Okay, now we can build the ionic equation of Cu2 plus O2 2 minus. That was the wrong color, I apologize. Once I do that, we can do the LCM for balance. Between a 2 and a 2, the only LCM can be 2 because that's the lowest that they'll both go into. Then you can make your LCM table. So you pull down your anion, Cu, and we know what the charge number is 2. And then we pull down our anion, O2, and we know that has a charge of 2. And we're just worried about the charge number, not the positive or negative. We know that we're going to make the equation of this times something is going to give me the LCM of 2, and this times something is going to give me the LCM of 2. Well, when we make this true, we get our subscripts. So Cu, 2 times 1 equals 2, it has to be 1, because 1 times anything isn't of itself, and those two are the same number. So that also has to be true for O2. So then we can write our balanced compound knowing that we are going to be writing 1 as a subscript because you only write subscripts of 2 or higher. So we're just going to write it as Cu O2. Okay, we're going to do one last example of the LCM method, and that's going to be copper to nitrate. Okay, the first thing that we're going to do, like always, is separate our cation from our anion. So we look at copper 2 nitrate, and we see that copper 2 is written first, so that has to be our cation. But if I didn't understand it that way, we could look up copper on the periodic table and realize it's in the transition metals, and metals are always cations. And because it's a transition metal, it may have multiple oxidation states, meaning it have more than one charge. So you have to be given the charge in Roman numerals. That's 2 I's right here. So our cation can be written as Cu2 plus. Then we have nitrate. Nitrate, we know is the anion because it's written second. We also know it's an anion because nitrate is a negative polyatomic. So we can write this as NO3 1 minus. Now that I separated my cation from my anion, I can write my ionic equation of Cu2 plus NO3 1 minus. Now that I've done that, I can figure out my LCM. And for my LCM, I can go and look between the 2 and the 1. We know that LCMs are rarely 1. They're only 1 if they're both 1s. So the lowest one that both 1 and 2 will go into is a 2. Okay, from this, we can make our LCM chart. So from our LCM chart, we can see Cu, and then I can go ahead and pull down my charge number of 2. And for NO3, I can go ahead and bring down my charge number of 1. Now I can go ahead and make the equation of, so 2 times something is going to make my LCM of 2, and 1 times something is going to make my LCM of 2. Now I can finish this equation. 2 times 1 is going to make this equation 2, and 1 times 2 is going to make this equation true. Now I can look at my balanced compound. So I look at copper, I need 1 of them, so I can just write copper, Cu. But now I'm looking at NO3 and I need 2 of it. Now remember, NO3 is a compound. So if you need more than 1 of a compound, you have to put them in parentheses. So I pull my NO3 down here, but I remember to put my NO3 in parentheses because it's a compound. And then I go ahead and put the 2 on the outside of the parentheses. And then I'm balanced.